Okay, so you're given another problem, which this time seems to be a bit complicated. And you are told that, you're given these numbers and you have to solve this equation. Now, whenever you are given such kind of equations, the best thing to do is try to break it into its prime factors as much as possible. Okay? So you have basically 12 cube. Now, 12 can be written as 2 into 2 into 3 cube. Right? I've taken down these numbers. If you do the prime factorization of 12, this is what you will get. Into 5 to the power 3 into 8. Now 8, if you do the prime factorization, what do you get? You get 2 cube. Okay? Divided by 9. Now 9 can be written as 3 square, okay, to the power cube into 25. 25 can be written as 5 square to the power square into 6 square. You can write this as 2 into 3 square. So does this solve my problem? Well, to some extent it does. Okay, but to some extent, I guess it's still a maze. Let me try to solve this further. Now, let's see one by one. Let's see this part. What equation can I apply here? Remember, a to the power m into a to the power n, or rather b to the power n, is equal to ab to the power, I'm sorry, I guess I've kind of used the wrong equation. A b to the power n can be written as a to the power n into b to the power n. Now in this case, what you have is that instead of AB, you have C. But that should apply equally here as well. So you can write 2 into 2 into 3 cube as 2 cube into 2 cube into 3 cube. A to the power n, B to the power n, and C to the power n into 5 cube into 2 cube. So now I have all the numbers as 1. Let's see this part. We know that a to the power m to the power n is equal to a to the power m into n. If you apply this here, a is equal to what? 3. So you write this as 3 to the power m into n, 2 into 3 into 5. Similarly, m and n, so 5 to the power 4 into a, b, n. So you apply this one, you get 2 square into 3 square. Right? Now, just to make life more simple, you add this up. So you know that a to the power m into a to the power n is equal to a to the power m plus n. Right? So what I do is I take them one by one. I first take 2. So what do I have? 2, 2, and 2. So I can write this as 2 to the power 3 plus 3 plus 3 into 3 cube into 5 cube. Now again, 3 to the power 2 into 3 is how much? 6. So you have basically for 3 also you have this and this. But I'll put 2 first here. So I get 2 square into 3. 3, 6 plus 2. 6 plus 2 into 5 to the power 4. Right? So when I solve this, I get 2 to the power 9 into 3 cube into 5 cube divided by 2 square into 3 to the power 8 into 5 to the power 4. I'm running short of space, so I just kind of remove this. Now, for 9, basically you can also write this as 2 upon 2 to the power 9 minus 2, 2 to the power 7, this portion. Similarly, this can be 3 to the power 3 minus 8. So this is minus 5, so it goes 3 to the power 5 into 5 to the power 3 minus 4, or minus 1. So this again goes 5 to the power 1. So the solution is 2 to the power 7, 3 to the power 5 into 5. This we know that if you have 2 to the power minus 2, this is basically equal to 1 to the power 2 to the power 2. So you change this to division and this minus sign will change as positive. Just to recapitulate as to how do you do it, you try to break in whatever numbers you had into its prime factors as step 1. Step 2, you apply various formulas to arrive at independent powers of all the numbers. Step 3, you then add up the powers of these individual numbers. And step 4, then you basically align them in such a manner so that you can divide them, and then division will take to the subtraction of the power mode. And you get your solution.